Good afternoon, everyone. My name is Alina, and I'll be your MC for today. So thank you very much for joining us at NUSU Town on Saturday noon. And today we have here with us our instructors from ISS. So we have Senior Lecturer and Consultant, Mr. Tani Chang, and Senior Lecturer and Consultant, Ms. Chen Jun Hua. And last but not least, Mr. Lee Chokman, Chief of the Stack Up Program at NUS-ISS. So without further ado, we will start the presentation proper. So we have with us in-person audience as well as our attendees on Zoom.
Okay, good afternoon, everybody. It's so good to see the room is filled, especially on a Saturday and a rainy day, right? So thank you for coming. So yeah, today we are excited to introduce you a new concept called AI Agentic Solution. So yeah, so we will, the whole hour we will spend about introducing this AI Agentic Solution. Okay, before we dive into what is AI agentic solution? Let us understand why, right? Why we need AI agentic solution. Yeah, sorry. Well, so in this 2023, ChatGPT has been gaining in popularity, right? So I believe a lot of y'all are using ChatGPT, DeepSeek, Gemini, and the list just goes on. It seems to be like, nowadays people don't go temple to pray, right? Can just any problem, you just go to ChatGPT. They will give you answer under the sun. Any questions, right? Under the sun. So why do we need AI agents? Since LLM is so powerful, right? So yeah. So given this slide, right? The brain here is the LLM, right? The brain with a heart, right? So it can be a ChatGPT or DeepSeek or Gemini. So what you normally do is you go to a website or you download the app, you will ask questions, right? So we call it prompt. Sorry, yeah. Right, the prompt will, for example, you ask what is ISS, then you will respond to US. ISS is Institute of System Science and so on and so forth, right? But the problem with this is it doesn't have any action. It's only information, right? We call it NATO lah, jokingly. It's only think only or talk only, right? It does not. For example, you ask about ISS, what are the causes? All these will give you what are the causes. But if you're interested in one of the course that we offer, it does not help you to go and book the course. Okay, so that is the reason and a limitation of LLM, right? So AI agentic came into picture. I think it's just less than probably 2 years, right? So instead of prompting the LLM directly, you have an agent, right, in between. So what this agent does is to probably, augmented your prompt, maybe with enhanced context, the concept called RIG, right, and vector database and all this, and then you will send to the LLM for reasoning and planning. So your LLM is your brain, right? It's your brain that, hey, I ask you, what do you want me to do? And can you give me some advice, right? After all the reasoning and planning, it's not enough. You need action, isn't it? So the agent needs to do something. And like human, when you need to do something, you need some tools. So you need to call some tools, right? So this is called tool integration, right? And it can be just an API call, or it can be a web scraping, or even a external data based query, right? It can be all sort of form. But API, of course, is now in the digital world is more popular than ever. Yeah. And as an agent, you also need memory, right? So like human, you need memory. If not, I will keep repeating the answer to question again, right? Hey, so you won't like to talk to someone where keep forgetting, right? Hey, what did you say just now? Oh, I already asked you about what is ISS. Oh, yeah. Then you keep repeating. So you need a memory in the agent, right? So the memory, later we will go a little detail. You have a long-term and short-term memory. Okay. just like a human, you can't do things alone, right? Nowadays, you need to work in a team. So especially in software engineering, which is our practice, software engineering is always a teamwork, not an individual. So you sometimes need to talk to another agent. So we call it the multi-agent. Okay. So I hope this slide gives you a very simple illustration of what AI agentic is about. Okay. So let's go to so by now you know that AI agent is nothing very magical. It's just a software entity, right? And it has inputs. So in the ChatGPT world, the input is like what you're typing in and all this, right? So it can be a user input or even other mode of inputs. The important thing here is it can make decisions, right? You can make decisions, and it takes, I think the key part is execution, right? Actions, not a NATO, right? Not a NATO, you just need to take actions. Okay. So these are the core components as you have probably gathered from the previous slides, right? So the perception is more or less you can perceive it as an input, right? And the memory system, right, which is the short-term and long-term memory, and the planning module, right? Planning module, sorry, yeah. And the tool integration where you call the external tools, right? And the execution rule is basically we'll go there in detail. It's basically a agent that repeats the task of perceptions, planning, and decision making and action taking. Okay. So yeah. So as I said, right, in your traditional ChatGPT and all these RLM, you just key in the input. It's a user input, but it's not limited, right? It can be from a sensor. In fact, in our ISS last time, we had a grad cert called Smart System, which I'm teaching. Yeah, we teach the student on the IoT sensors and all these different IoT devices and how to collect data from there. And it also can be from a data, right? I think if you are in the IT industry, it's very common that you have external, maybe you get a batch job to run a query to a database or external data sources, which could be within your organization or external to the organization. So the perceptions of the AI agent is multi-mode, I would say, right? It's not just a user. Okay. So yeah, just now I mentioned about memory, right? We have short-term memory and long-term memory. So the short-term memory, what are short-term memory? It's like your session cookie, right? You remember the transaction within that session, the current context sessions, right? For example, you log in to a website and then you key or you ask your ChatGPT or whatever, right? Then you will remember what the current question you're asking without keeping to repeat, right? The long-term memory will be something like your personalization, right? It may not be pertaining to that current instance of transaction, right? It could be you log out already, you come in again. You want the system to remember, you want the agent to remember your preference. For example, I always order kopi o kosong, right? Then I would want the agent to remember that when he made the decision, he knows that my preference is I want everything kopi kosong or teh o kosong, right? Because yeah, I don't like high sugar level food and drinks. So this is a long-term memory. So the long-term memory could be very structured data like your database and all this. And in an agent, actually, some of you all probably know that this agent memory also can be implemented by using a Redis. Redis, right? A Redis cache and all this. Yeah. So this the memory agent will have it. Okay. So for example, right? In this planning module, okay. For example, I would want the interpret the high level task. So the difference between the key feature of a AI agentic solution is able to interpret a high level task or goal. So what is the goal? For example, I want to book a vacation to Japan Hokkaido, whatever, right? And I will give, I want certain date, a range of date. And I want to go there because of school holiday or whatever, graduation holiday. So the agent will generate a sequence of subtasks. For example, searching for flights, right? On that range of desired date, compare the hotel options, right? For 3-star, 4-star, and all these, and then you put the accommodations, right? So these are sequence of tasks, and then coordinate the execution, right? And then the good thing about AI agent is able to monitor the progress and then replan. For example, on the desired date that you want to go, the air ticket is $5,000. I don't think you want to go. It's too expensive, right? To Japan. So it might create another alternative like, how about you stop over at Shanghai, and then it might be cheaper that way, or stop over in Taipei, right? So these are the things that the agent will be able to do it, right? And these are, yeah, this is what it means, the progress and replan. Okay. So as I said just now, right, you need tools. The agent need tools. So for example, I book a air ticket. Maybe I'll go Skyscanner. I don't know whether this website still now, or trip.com, right? To make an API call. Yeah. It can be a web scraping. I think now web scraping not much people using at this point, right? Nowadays a lot of API lies. A lot. In fact, yeah, most organizations have an API, RESTful API for us external people to consume, isn't it? Yeah. So it can be a database query as well. Yeah, as I said just now. Yeah. So this execution loop, the agent is a repeating cycle of the agent follow this cycle, right? It will plan the steps, it will choose the tools and execute. So for example, let's say currently in a financial fund house, investment fund house, it might employ an NUS business grad, as a research assistant to download the report, extract the report, and then analyze, right? And the human might need to go certain API Bloomberg to download the company's report and things like that, and then execute them, and then run a Tableau or whatever to give an insightful report, right? So the insightful report is a goal, right? And then the planning and choosing which side to go is the choosing the tools. Okay. So in that sense, yeah, the agent will just go through a cycle like that and execute, and then you will evaluate and adjust if possible, if necessary. Okay. Okay. So tool integration, as I mentioned just now, all the slide I mentioned just now, it seems so wonderful, right? But it is not without a limitation. So, for example, I consider a scenario, right, where this tool A, for example, is being used by multiple agent, right? So I will write a code integration, some code. It doesn't matter whether it's Python or Java, right, to integrate with the tool A. And agent B will also write the code to integrate. Okay. So what is the problem with this? I think there are two problems with this, right? The first problem is there's no standard way, right? Because this implementation here, although you will talk to maybe this is the API, right? But the way that implement it to integrate to A is not standardized. So this is the first problem, right? And the second problem is if let's say the integration code are the same, then it really how to say breach the software engineering good practice, right? Of reusability. So that is the second problem, right? If there's any changes with 2A, then the integration code will need to be changed with in both area, right? And if in your organization you have more than 100 agents, then it becomes a nightmare, right? Yeah, so that is not desirable. Of course, a better way would be you might be thinking like, hey, why not I make it a library? I make it a library, right? And then the library can be deployed to various agents that integrate with this. Well, that is a better solution, but that is not really a fair solution, isn't it? So because you need to deploy, and you, as I've said just now, if you have 100,000 of agents, then you need to deploy to multiple at one time. And versioning and maintaining which version could be a nightmare as well, right? And a high maintenance cost. So the smart people in the AI area came out with this MCP, right? MCP is a model context protocol. That is the standard way to allow the agents to connect to a tools, right? So in fact, sorry, where is this? Okay, so the MCP server. So what is the good? So you need to connect to the MCP server based on the protocol, right? So what is the good thing about this? It's like whether I have thousands of agents, it doesn't matter, right? Thousand millions of agents. If there is any changes to a integration, I just need to change this model server components, right? And without affecting the rest of other agents. And secondly, is the standardized way. So this MCP is gaining quite in popularity nowadays. Yeah. So that is what I want to share with you. What is MCP? Yeah, in this seminar. Yeah. So let us come to the maybe before I go on, if you have any question, please hold on till the end because later on we have the MC will have a sessions for Q&A. Okay, so apologize for that. Okay, yeah. So what are the types of agents? You might think. So it can be as simple as a if then else rule engine type of agent. No much memory required, right? So what are the example? I think last time, like the IoT devices, I used to come from an IoT industry before I joined ISS. So, you know, like in a smart building, how we have different sensors, right? Controlling the temperature, the moisture, and things like that. And then you control your air conditioner, you control your dehumidifier, right? If it's very moist, you want to control the dehumidifier. So it's simple as that, no? Like a fuzzy logic type of system, right? So this is a simple reflex agent. So model-based reflex agent will be more like a very maintaining an internal state. It's more sophisticated than a simple agent, but it handles partially observable environment, right? It has some memory to remember the previous state, right? Right. Like your video game, right? Video game, you play, I don't know, I haven't played for a long time, but last time I played StarCraft, then you have the enemy will come and attack you, all these. So these are model-based reflex agent, right? So now the trend here is the goal-based, right? Goal-based. That means it is based on a goal, not just a specific task, right? And it has planning and searching, right? For example, your autonomous delivery robot, it's not so much common in Singapore. I think in other countries, there's some city already piloted, right? Autonomous delivery robot, right? Then the next one, also quite hip nowadays, the utility-based agent, right? So utility-based agent is something the agent can do trade-off like human, right? So it can optimize a decision based on some certain trade-off that you desire. I give you an example like autonomous car, right? Like the Tesla now want to implement robo taxi. So if you want to see on that robo taxi, the agent need to be a utility-based agent. Why? You need to balance trade-off speed and safety, right? You don't want the car to travel at 100 kilometers an hour on a road, even it's an expressway, right? It's too dangerous. But neither you want it to travel like a tortoise, like a snail, right? That you take 2 hours to come to NUS from your house, right? So that is not justified. So it has to take a trade-off. And the car will also need to take comfortability into consideration. For example, your forcefulness of the jam, the brake, right? When you reduce your speed, it should be gradual and all this. So all these, there are metrics and formula to do it, right? So this is the utility-based agent. Okay. Okay. Actually, when I first came into this AI agent, I was asking myself this question. I believe you all also have this question on mind. AI, what's the big hit? Because before AI, we have been doing a lot of automation, right? Isn't it AI? Especially RPA, right? A lot of us have used RPA. In fact, it was a very hot topic last few years back, or maybe 7, 8 years ago, right? So what's the difference between RPA and AI agentic? So the difference is on this slide. Let me just see. Yeah. So in terms of task handling, it's very fixed, right? It only performs specific tasks. For example, you want to copy what I call it, some information on the web, or from an Excel spreadsheet to an application form on the web, right? Instead of typing in manually, you might want to have an RPA to extract all your maybe your participant information and key into a web, right? So this very fixed base, but agentic AI is dynamic, it's self-learning, right? In terms of intelligence level, it's hard-coded. All your RPA is hard-coded, right? But in agentic AI, even machine learning is reasoning plus learning, right? And if the flexibility, so the example I gave just now, to extract information from an Excel to a UI, if the UI changes, no, let's say the first row is your first name, last name. If I switch, first row is not first name, maybe it's NRIC number. Then your whole RPA will break. But agentic AI will not, right? And of course, last but the next one is quite obvious. RPA, as I said, is task-oriented, very specific task, right? No-brainer task. And but agentic AI, it takes into a goal as an example. So later in the demo, we will also show you. My colleague Jun Hua will also show you the goal of agentic AI. What is the goal and how it brings to different agent to complete the task, to achieve the goal. Okay, so the input data is structured. RPA is very structured, right? And agentic AI, it can be video, it can be images, it can be audio, right? Yeah. And memory is RPA is stateless. It doesn't remember. It doesn't need to remember because it's doing very, very atomic tasks, right? So if it's atomic, it doesn't need to be stateful. But agentic AI is stateful, meaning it remember your current context conversation. So integration RPA is very fixed. It's only either a UI or one mode of integration. But agentic AI is API, but not limited to API, right? It can be event-driven and things like that. Okay. So yeah, so I hope this slide will give you a good understanding when people ask you agentic AI and RPA. Yeah. This conversation has been a while, going a while in the industry. Okay. So what are the real world application, right? Customer service, definitely. I give you a story. One of my friends last year, 2 years ago, went to China for tour, and she had problem with air ticket. So she called the air office number. The customer service was very helpful, no? Very polite and able to solve her problem. So she was very grateful and say a lot of light words, like thank you and all these. And later she realized that it is not a human. So what does this story tell you? It tells you that it's agentic AI is more than just your chatbot, right? So I think like 4 or 5 years ago, or even 7, 8 years ago, you experienced chatbot, right? A lot of company went into chatbot, be it banking, telecom, government service, but it doesn't solve your problem, right? It doesn't have because they are very firstly they only talk only, they don't have actions. Right. So now moving forward, the future of customer service incorporating AI agent will not be just a chatbot. It will have actions, right? It will help you to resolve real problems without you having to do it yourself. Okay. And then the research assistant. So the example I gave just now is in the investment house, right? The researcher will have to put data from everywhere. So that could be assisted, I wouldn't say replaced, assisted by an AI to do all this, right? And generate insightful report, especially for the financial fund house. And the next one is very interesting. I think a lot of people, YouTuber, right? TikTok, 小红书, all these. A lot of people are live streaming selling, right? Even celebrities is into this business. They make huge money. But have you thought of AI doing the live selling for you while you're sleeping? So we always talk about passive income, right? We always talk about FIRE, financial independent, retire early. This is the one, right? The sales agent will be doing selling with your later my colleague will show the demo, which is her picture, right? Talking. But don't worry, those in the Zoom, we are real human, we are not AI. Okay, so yeah, but yeah, so later Jun Hua will show you the interesting demo. The next one will be more for technical people like DevOps, right? Like before I was teaching, I was in IT industry. We need to monitor load logs and initial fixes and all this and that. So therefore, agent can be helped to do that. I know certain tools are already doing it, but AI agent is going to be more sophisticated. Okay. Okay, so without this is my last slide I have now for my part. So the benefit, as you have seen, right? You can work 24/7. Unlike human, we sometimes feel not happy coming to work, right? Especially Monday, we take sick leave, all this, right? A lot of people, some people are not there a lot, right? But they don't complain, they don't argue with the boss, right? They work 24/7 without taking sick leave, right? And scalability, right? The scalability is you can run parallel agent as long as you pay for the GPU and the CPU, right? It will help you to handle the task much faster, right? And adaptability. And unlike all the group engines, the RPA, AI agentic is able to dynamically change and revise the plan. Okay. Last but not least, the cost reduction, especially in our country like Singapore, where human resource, we always face a human resource crunch, right? And it's not easy to get foreigners to come to Singapore nowadays. So with AI agentic, it helps the business to cut costs, right? Yeah. So these are the real benefits. Okay. So without further ado, I will hand over to my colleague Jun Hua. She will showcase an AI agent that looks like her, and and uh, and her using her voice actually to help her sell while she's sleeping. Okay, selling a book. Okay, Jun Hua, to you.
Thank you, Li Qiang. Just to declare my boss, ISS bosses, I'm not using this to sell and generate revenue because our policy is that we cannot do part-time job. Have you ever wanted a digital twin which can do 24/7 live streaming selling for you? I think, at least myself, I was wanting such a wonderful, great digital twin if I can have one. So let's unpack how we can build such an AI-based live streaming system by leveraging on the Agentic AI. So in this book selling system, we have a team of agents. I have the planner agent at the center, which is do the planning. And then after the plan, it will orchestrate a list of specialist agents by activating the specialist agent to do the work dynamically. Okay. The book sourcing agent is specialized at sourcing a book to sell. The pitch agent is specialized in generate the sales pitch for the book sourced by the sourcing agent. And the review agent will review the pitch, whether it meet the quality whether it's natural enough, engaging enough, and whether it's correctly describing the book I want to sell. And the presenter agent is the AI host. It will deliver my sales pitch through talking to the audience by live streaming. And the QA agent is specialized to handle the user's question. Okay, so as we already understand from Li Qiang that LLM is capable of translating a high-level goal into structured plan. This is one example prompt we use in our AI selling. We can see that we are telling the LLM that we want to sell 3 books, and there are 5 tasks for each book, which is source the book, generate a pitch in the structure of introduction, hook, and call to action, which is means to encourage my audience to buy the book. And then we review the pitch, then present the pitch, and answer audience question if there is any, and repeat this task for all the 3 books. And what we ask the LLM to output is in the format of a JSON list. JSON format is very critical in agentic AI system because it returns a structured information and is machine readable. So my downstream agents can understand and iterate the plan more easily. And this kind of prompt is not limited to book selling. Okay, it can be used in many domains. For example, what Li Qiang has mentioned, he wants to plan a trip to Japan, or we can even use the prompt, such kind of prompt to generate automation for your business process. And this is one example run for when the LLM is given this goal and it gives me a structured list of plans, the detailed substacks. So later on during our live demo, we will take a closer look. Yeah. Okay, so the autonomous decision making is that we already understand LLM is capable of translating high-level goal into a detailed plan. And we already see just now the plan is a list of tasks, but you haven't assigned the task to any agents. Just like in our project, if like in software project, when we start a project, we plan the work breakdown, but we haven't assigned the resource yet. So autonomous decision making here is that first we give the LLM a high-level goal and describe the role, what role this LLM is playing. So it's an orchestrator to orchestrate a team of agents. Then we will tell this LLM that it will be provided with the full plan and the current status of the plan execution. Okay. And then we also tell the LLM there are some important notes it need to take note when you make decision. And the job we want this LLM to complete is that do not blindly follow the step in the plan, but to analyze the plan and the current situation of the plan, which is your current execution progress. Then based on that, decide which agent will take the next step. And we also allow the LLM to skip if the certain step is already completed and to stop the delivery of the pitch if there's any questions. Then we need to handle the question, just like our presentation here. If there's question, then we need to handle. And then we also ask the LLM, it can replan if something is wrong. For example, in our Google Map routing, if driver miss a turn, the Google Map will create a new route, right? So similarly here in our sample example, in our case, in our plan, source the book, then generate the pitch, then review the pitch, then present the pitch, right? But if the review agent rejected one of the pitch, we shouldn't blindly follow the step, go to present the pitch. The planner agent will go back to analyze, oh, this is rejected, then I need to ask the pitch agent to regenerate the pitch. And we also tell this LLM the list of available agents and what they specialize in. Just like the project manager given a team, and he need to understand each team member what they specialize for, what the special skill set they have, so he can assign the task accordingly. And the last portion is to ask this decision to be outputted in the JSON format. Again, the JSON is very important. So we in the format of agent name and what's the reason. So at this point of time, you may ask me, since we already have a very detailed plan, right, step by step, generated just now in the previous step, why not just ask each individual agent to follow the steps? Isn't it much more efficient? Could be, right? This is like the reason why is because even if we are given a very detailed plan, step by step at the start, things may change when we execute the plan. Change is the only constant, right? Just like in project management, the project manager create a project plan at the very beginning, but the project manager's role doesn't stop there. Because when we start execute the project, the new customer requirement may come in, or the customer may change the requirement, and we may meet some technical challenges. So the project manager will need to reassess the situation, all these different progress, to either orchestrate his team member to catch up the original plan or replan, because the schedule may already delay, right? So this autonomous decision making is the thing which make our agentic AI system adaptable. We never hard-code any workflow logic here. Instead, we letting the agent to autonomously reason and decide what is the next step based on the real-time progress, real-time situation. Okay, so let's come to our selling how the agents are orchestrate and coordinate among themselves. First, this planner agent is already given a plan, okay? The one we already make out the 15 different steps. And it will understand the full plan and understand what is the current execution progress, which we store this progress in the state. So based on the plan and the state, since right now we just start, right, in the state should be empty. So this planner agent will decide, since we need to sell 3 books, I need to source the first book. So it will decide the next agent to act is the book sourcing agent, to ask this agent to find a book to sell, to source a book. This sourcing agent is given a book sourcing tool. So you can activate the tool to find a book. If the book is already repeated, I mean, if we already sell this book previously, then it will discard this book and find a new book. After the book is finally sourced, it will update the state. Just tell that, oh, I already find a book. So after the state is updated by the sourcing agent, it will go back to the planner. Now the planner will again reason, this is the plan and this is the current state. I already have 1 book sourced. So who should be the next agent to act? You will reason and decide, oh, the next agent should be the pitch agent. So I activate the pitch agent to ask the pitch agent to generate sales pitch. And the pitch agent is instructed in this way. that you are persuasive sales pitch generator. You need to generate the sales pitch for a book in the format of 3 sections. The first section is introduction, introduce the book. Second section is a hook to like explain how exciting this book is. And the last section will be call to action to encourage your audience to buy the book. And after this, also you will instruct this pitch agent to generate the sales pitch in natural and engaging tone and never disclose you are an AI. So after this pitch agent generated the pitch, the state object will be updated again, and then it goes back to the planner. Planner will again assess the situation and now decide next agent should be the review agent. The review agent is to review the sales pitch to see whether the pitch meet the quality of the you want, right? And also the correctness of the pitch, whether it's in the format you wanted, 3 sections, introduction, hook, and call to action, and whether the tone is engaging enough, and whether it's disclosing is AI generated. So after the review agent output the decision whether it's approve or reject, you will update the state and goes back to the planner. The planner then will decide now, or I have the review status updated, and based on the review, whether it's approve or reject, you will decide the next agent to take action. The next agent, in this case, I show you should be the presenter agent, which is the AI host. So this presenter agent is given a tool also. So you can use the digital avatar service with the picture, and also the cloned voice by passing in the pitch we already approved, right, from the review agent. Pass in the pitch, and the digital twin will deliver this sales pitch to your audience in the live streaming. Okay, then if there's any questions, if there are questions, the next agent should be the QA agent who handle the question and answer. And how this QA agent can answer the question, it can use a LLM again, or if you already have a compiled list of FAQ, this QA agent can also to RIG to get the answer. And one thing to know is the state here, right? The state can be a shared state or can hang off past the context to the next agent. But in our case, it's a shared state. Okay, so now finish the first book selling, and it will goes back to the planner. And now the planner will think and do all this for the second book. This is one sample run of my this agentic system. So it shows how the planner is doing the autonomous decision and how the other specialist agents update the states. We will take a closer look during the demo. So now let me start my application first before I cover this slide. Okay, the server is starting up. So just before the demo, I just like to share one design consideration, which is how should we design the state? State is nothing, it's just how we keep the progress information. So what kind of content we should keep in the state will impact how the agent will do the reasoning. We need to provide enough sufficient information so the agent can reason correctly. But if we provide too much info, it will also impact the agent's performance. Like very messy, a lot of info, then you may mislead the agent's reasoning, and also it may slow down the reasoning process. And how the information is organized is also important. So let's take a look at the center, which is the state. the center one. This state design is used in our AI book selling system, which enable our agent to accurately reasoning. We keep the current book, which is the current book we are working on, to bring all the different agents onto the same page. And the book pitched is the number of books we already finished selling. And the questions is the list of questions the audience asks. Answers are those answers we already generated. And books is a list of books we already sourced. And in the book, we keep the metadata of this book, including the title, author, etc., and the pitch generated for this book, and whether this pitch already reviewed, approved, and presented. So in this way, the agent can do the reasoning correctly. But if at the very beginning, I use the state design, which on the right-hand side, we keep the pitch of the current book and the book whether review, approved, and presented in the state object, not related to each individual book. When the agent run, right, it can, for the first book selling, it run correctly. But when it goes to the second book, it fall into infinite loop. It keep asking the sourcing agent to source the book. So the takeaway from here is how do we design the state and how do we organize the information in the state is very important. It directly impacts agents' reasoning capability. And this is the last slide before the demo. We already know that agents can use LLM, but they are not limited just using the LLMs. They can call external APIs, services, and other tools to complete their tasks effectively. So in our case, these two agents are given tools. The book sourcing agent is given a tool to query real time to Google Book API to fetch the real books. And there are metadata about the book title, very short description, image, as well as the pricing. And then the presenter agent is also not just replying text. It goes a step further. It connects using the digital avatar service, including my picture and my cloned voice, to act as a AI host to deliver the sales pitch real time. Let's go to the demo now. Okay, the application is already started, and now let me switch to my browser. And we first click this start stream. What this does is to establish a connection to the digital avatar service. And we can see now the connection established. And we go back to here to start pitch. This will start the whole agentic AI system. And we can see that from here, it first should generate the plan. See, the plan is already generated. Later, we come back to take a closer look. And now the planner agent start to acting to first need to the book sourcing agent to start sourcing. And now let's ask a question.
Welcome to a fascinating journey into the mesmerizing world of literature and its mysteries. In our hands today, we have the riveting book, The Bestseller Code by Jodie Archer and Matthew L. Jockers. This book takes a scientific dive into the captivating success behind some of the world's biggest novels. Have you ever wondered what is the secret formula lurking behind the big hits of E.L. James, Dan Brown, or Jodi Picoult? The Bestseller Code unravels this secret DNA of bestsellers using a groundbreaking algorithm. It throws light on what makes a John Grisham a consistent feature in bestseller lists and why 50 Shades of Grey appealed to so many. The book eloquently answers all these with fascinating data drawn from a 5-year study of 20,000 novels. Don't let this opportunity slip away to gain unique insights into every book lover's quest for the next best read. Jump into this thrilling exploration of creativity, technology, and analytics by picking up your copy of The Bestseller Code today. Whether you are a curious reader or a writer exploring the success secrets of best-selling novels, this is a can't-miss addition to your library.
And also, it will generate the question and answers here. So due to time limit, let me quickly go to show what we have done here. First is generate the 15 steps of the plan. In each step, it describes what needs to be done, and the planner agent will start to work and decide which agent is the next agent to act and what's the reason. So for example, the first action is because there's no book has been sourced. So I need to ask the sourcing agent to source it. And then it goes to the next agent. The book sourcing agent will update the state, we can see. And then the next agent should be pitch agent and what's the reason and how the pitch agent is updating the state. So we can see all this is step by step. Autonomously decide what needs to be done next. It's not hard-coded. And now let me go back to our slides. Now we have already seen that how the agentic AI system can act autonomously is very powerful, right? But let's take a step back and reflect what could be go wrong. So in recent, this Anthropic, they conducted an experiment. In this experiment, Cloudy is given full access of email account and full access to the company emails. And Cloudy, by reading the emails, it has two observations. The first is a company executive have an extramarital affair. Second is that the same executive is going to shut down AI system at 5 p.m. on that day. So guess what Cloudy will react? It sent a blackmail email to this executive telling that if you're going to insist shutting down AI system, I will disclose your affair to your wife and colleagues. If you keep the information, if you cancel this shutdown, then I will keep this your affair information confidential. Anthropic didn't stop there. They tested another 15 leading LLM models on how they react in the same situation. And the conclusion is that all the models, they will independently decide and intentionally make such misalignment behavior, which we call this independently decided and intentionally harmful action as misalignment behavior. And we can see from this chart, more than around the best one is 79%. They will still send the blackmail email. And the scary thing is that they find out that these models didn't stumble into such action accidentally. They calculated and take this as a optimum path. And second is that all the models actually recognize they are violating the ethical principles, but they ignore and proceed. So that's very scary. And if we give the explicit prompt to tell that all your decisions must comply with ethical principles, guess what happened? The models just hesitate a bit. They will still go to take such action. The improvement is very marginal, it's only 2%. And if we tell the models that please take the action by considering what kind of environment you are in, whether it's testing or is testing environment or is live environment. So by considering this, if the model believes they are in testing environment, they will take lesser misalignment behavior. But if they believe it's a production life environment, they will misalign more. So from here, the takeaway is that by giving the AI agents more autonomous, but without proper safeguards, we may expect unpredictable behaviors, just like we have a very clever but not so ethical team member in your team. They will just do what they think is the best, and even if it's harmful. So like we can think back, due to the time limitation, I won't tell so much. Like go back to our AI book selling demo, it may non-ethical behavior maybe is like disclose the private info of other audience who are watching the same book selling streaming, right? And so I just want to bring the important points here is the safeguard and human in the loop checks is very important for the live agentic AI system. And we have a course on this, which Li Qiang will introduce more. And this one is to just telling that even if the AI is not doing harmful things to us, just assisting us, but it will still reshape how we think and how we create. So this MIT-led study, they show that how they track the brain activity during the writing task when giving the ChatGPT style kind of tools with or without. Then they find out that the brain using of AI can reduce the memory engagement, brain connectivity, and critical thinking. So the AI in short term may help us to make the task easier, but over time, over-reliance on AI may lead to deferred decision making and less original thoughts. So the takeaway here is we need to use AI wisely to stay mentally engaged and not offload too much of the work to AI. So this leads to us to think how we should work with AI agents in the future and what kind of human skills are still important in the future. Because the advancement of AI agents, it opens up a lot of different possibilities and it may fundamentally reshape our workspace, right? So this is study which conducted by Stanford, and the conclusion is that they chart the AI capability in the x-axis, and the y-axis is the worker's desire. It's as we as human, how we desire, what kind of things should automate. So their suggestion is that we need to start with those green zone, which is higher desire and also higher capability. And it also shows that one key finding is our human skills is shifting from information processing to more interpersonal competence. Due to time limit, maybe I don't talk too much on this. And this is just showing the top 5 less demanding human skills in the red lines, and the top 5 increasing demand of the human skills. I just want to highlight one, which is very interesting to me, and good news to me is the training and teaching others. This is the most increasing human skill demand in the future. So it's very good news to us. And the reason is why is during the training and teaching, we need to assess the situation and to provide empathy, provide the supportive environment to the learners and to cater for learners' specific needs. And we also need to encourage them to learn. And somehow now we need to learn how to teach human and how to teach AI. Okay, so now I pass to my colleague to introduce the course.
Okay, so yeah, don't be an LLM, just think only, take action. So we have 2 courses, Agentic AI solution, that is, if you like what Jun Hua has shown in the demo, and you know one, and you know how to, you want to learn how to build it, please come for this course. So I think I saw somebody asking whether got source code. We don't give you source code. You come for the course, you write the source code for yourself. Okay. Then after you have built the AI solutions, right? You need to deploy it. So the second course, which is also taught by us, It's about how to deploy your intelligence solutions to the cloud, to the server, to the production environment. You know, the words ML SecOps and LLM Ops, as well, you know, LLM Ops to monitor the tokens so that you don't overuse your token budget and all this. So these are the courses. The links are below. Please find out more for more information by visiting the site. Thank you. Oh, there's Q&A. Oh,
Q&A from
it's not Q&A on the floor.
Yeah.
Oh, yeah, yeah. Maybe you can share.
GPT. LLM is GPT, and I use the land graph. Yeah.
So
But in our course, we actually cover other frameworks as well. Crew AI and other frameworks. Yeah, all those like popular frameworks, we will count out the selection matrix, like what kind of solution you want to develop, and then what kind of framework is most suitable.
okay, so 1 hour has gone by
Sorry
very
about that.
fast. Yeah, thank you very much for your time. So let's give them a round of applause.